So last week we had a session on data cleaning with dplyr with the intention of transforming messy data into meaningful insight. In general, we had an introduction of what's a dplyr package, and then we covered the data set that we are going to use. Can you see this?
Yes, we can see your screen.
Okay, and it's displaying data cleaning with dplyr package.
Yes,
Then,
yes.
okay, fine. So, and then we said that we'll cover these dplyr verbs from select to arrange. Unfortunately, last week we only covered select, rename, and filter. We used a little bit of count, but apart from that, we only covered these three. So today we'll be tasked with covering the rest of this, and then we'll continue with the questions and clarifications. So as I said last week, dplyr package can help us in trying to convert our data from raw unorganized data into this kind of sorted data, then data which is well arranged, and then we can use other packages in try to make it visual appealing. And then we said we can install dplyr package in two ways. We can install it as part of a tidyverse meta package, which contains several other packages that are useful, or we can install it as a solo package, just like this, with this line install.packages, and then brackets in quotation marks dplyr. And then as always, before we go on with anything in R, we're supposed to call that package. So we'll write the code library and call that package before we go on with any analysis or with any data management. And then after that, we covered the data set that we'll be using, which was HIV data updated. And then this was the code that we used to update, to upload data to our system. As you remember, I had shared a file that had this as this .r data, .r history, .r profile data, and then it had this R project file, and then it also had this participant dplyr verbs RMD. And one of the reasons why we did this, it was because we want everyone to be able to reproduce what we are going to cover in that session. So this is one way of doing it. We will learn in the future, or for those who had attended the previous session, we could have done this with other package, but we did it this way this time, at least to omit that confusion as we try to cover all these topics. But there's another way of doing this. Okay, and then this was a data set. It had 17 variables starting from ID, and then it had 1,500 observations. And then after that, we went direct to the verbs themselves. And then we started with select, which we said is helpful in selecting a column of interest. So for instance, here we had A, B, C, and D, and then we wanted only A and C. In such scenario, select function could become handy. So we could use select for selecting the column of that we're interested with. And we also learned that we can use different operators such as colon. We can use an colon to specify the range of columns that we want. We can use the exclamation mark to exclude the columns that we don't want. And then we can use this function to explicitly say what we want. For instance, if you use it in percentage, percentage in percentage, it can be helpful to say that, okay, in this column, we want this, this, and this. But we also covered that we could use other helper functions such as start with, end with, contains, as well as everything. And this is how we went through that. This is how we could select a range from age to value load. And you can see in the output, we have range from age to value load. And we could also use the column number. So say from column number 2 to column number 7, and the output will look like this. So we could use the name of the variables, or we could use the number, the column number of the specific variable. But then again, we say that we could use the helper functions such as contains to select anything that contains the word date, or maybe anything that ends with the word gnosis. But also we could use the exclamation mark to negate the selection of anything that it is in our line. For instance, here we could say we have selected ID, date, date of diagnosis, and prevention management. But say we don't want just those 4 columns, we could just write the exclamation mark just before the C here. And then by doing that, it will select everything else with the exclusion of these 4 columns. And that's exactly what we see down here, that we have all other columns, but we don't have columns that are identified as ID, date of sample collection, date of diagnosis, or prevention management. Okay, so we didn't really cover this, but actually this is very simple. So sometimes you may want certain columns to appear at the beginning of your, in this arrangement. So you have your columns from age, gender, occupation, height, etc. So suppose we want the viral load to come after age, we can just select the column age, then the column viral load, and then we can write everything else. And then all these columns will appear as they were in the previous data set. So, and this is what happened here. So we want the hospital diagnosis to come from this side to come in the second column. And so it started with ID, then hospital diagnosis, and then by writing everything else will be arranged from here, going that way, based on how they were in the data set. And then after that, we came to rename, and we say this function is very useful in renaming our rows, our columns. So for instance, here we rename it from species to enemies. And what we said was we rename it by write the code rename, the function rename, then you write the new name, then you write the old name. And then after running this, the name will change from ID to ID number, hospital diagnosis to just hospital, as we can see here. Okay, and then after that, we went to filter, which we say this is very useful in selecting rows. So the select function is for column, and then the filter function is for rows. So it will select rows based on a certain condition that we want. For instance, maybe here, we wanted all those whose occupation was drivers, and that's what we get in the output. And then we saw how we could use the filter function with the different operators, such as less than, or maybe this one, percentage in percentage, which means A is an element of B. And then here we can see we are using this operator age more than 40, and we have that specific selection. So before I go further, this is a brief recap of what we covered last time. Do you have any questions or maybe need for clarification before we dive into what we're supposed to cover today?
Ludovic, I also see there is a request in the chat box if you can
Yes.
share the dplyr verbs PDF.
Oh, okay. So actually, okay, this is not a PDF. It's a HTML file, and actually, based on the RMD file that I had given you last week, if we continue to code these things together, at the end of the day, you can produce something like this. So, Frank, right? So I think, Frank, we can go on with the coding, and then at the end of the day, I'll tell you where to click, and then we'll have a file like that. Okay. Yeah, it's called an HTML file. Okay. Okay, so Okay, so maybe we can go ahead with what we're supposed to cover today. So, okay, so, okay. So today we're supposed to cover another verb, the muted verb. Okay, thank you. Okay, fine. The muted verb, and we can use the muted verb. Okay, so we'll go back to the file that I'd shared last week, and then we can start from there. So prior to do anything, come to this line 197 and then click this to run everything that's above, to ensure everything is loaded and all the packages are installed and we've loaded them. And then we'll start direct to the muted verb. So we use the muted verb chiefly. I use it for two things. The first one is to create a new variable. Suppose we want to create a new variable, or we can use it if we want to change the variable. So to create, or maybe if we want to, maybe we can use it to change the variable. So for instance, we can start with how can we create a new variable? Suppose if we look at our data set, for instance, we have age around here. So the age, I suppose they're in years. So here is 49 years, 26 years, 24 years, and then this is 1 year, etc. So suppose we are interested with, let's say, age of these participants in months. So it means 1 year is equivalent, let's say, to 12 months. So we need to convert all of this into month equivalent. So let's say we create another column. So we create another column, let's call it age, but age months. And this column will be equals to our previous column, age, times 12, because we know 1 year equals to 12 months. Okay, so if I run this, control, I'll get something like this. Okay, so maybe I should do something else here to make it clear. So select, let's say ID, age, months, everything. Okay, so what I've done is we have created a new column called age months, but by default, the new column was around here as the last column because it came last in this series. So I added the select function, the select verb, to take it from the last column to become the third in this series. So ID, age months. But what I really want us to concentrate on is this column, age underscore months. So here we've created another column which was not there. Originally, our data set only had 17. If you remember correctly, we had 17. Okay, so maybe we should come up here. Okay, I'll maybe can just run it. So I'll run it, this. So here we have 17 rows. We had 17 rows and 1,500 observations. But if you run this line, the mutate verb would have created another column called age underscore months, which will make now our variables to be 18 rather than 17s that we had previously. So in this way, we have created another column that we didn't have previously. So maybe we can go ahead and try to do maybe create another column. So suppose here we have height and weight. And when we have height and weight, what comes into mind? Maybe you can say we want to create a column called maybe BMI. So we may say HIV, we write the data set, and then we pipe that into mutate. And then what we want is a column called BMI. How do we get BMI? We get BMI by take weight in kilogram, right? And then we divide it by height. Height. Okay, so this is supposed to be height. Oh, okay. 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 So normally height is supposed to be in meters. So we'll have to do some things to take this from, okay. So maybe we should, okay. Here I'd pointed that we can use this to create a new variable. We can use it to change a variable. So here we saw how to create a new variable. Okay, so before we dive into this, how we can create BMI, so let's see how we can create, how we can change a variable. So let's see how we can change a variable. So because the BMI is going to be weight divided by height in meters squared. So we're supposed to change this height from centimeter to meters, right? So how we can do that? We can say, we can create okay. So we can say height meters equals 18 centimeters divided by 100, right? So this will create a new variable called height in meter, which is height in centimeters divided by 100. And then after that, we can go ahead and create a new variable called BMI, which will be weight in kilogram divided by height. So height in meters and then squared. So maybe I need to do this manually. I don't see it really.
I think you can use the shift number 6.
Okay, so okay, fine. That's looking okay. So this squared and then the brackets. Okay, so here, let's see if it will work. Okay. So let's see if we have a column called BMI. Yep, we have it here. So what we actually did, we created a new column called height in meters, because we know for us to get BMI, we need to have height in meters, which is here. So this column converted everything else that was in centimeter. The height in centimeter was around here. The height in centimeters by divide it by 100. And then we got height in meters, which is here. And then in the line number 211, we created the other column called BMI by taking weight in kilogram and divide it by height in meter squared. Yeah. So here we have changed a variable. Maybe we were interested in this variable. And now we've, actually here we created another variable, but we could actually, because it was meaningful this way, but if this variable was just called, for instance, height, not height in centimeter, we could have just written something like this. So we could have been height equals to, maybe this was just height, but it was in centimeter. We could have written height divided by 100. So this would have taken the height in centimeters, which was recorded before, and converted it into height into meters by dividing it by 100. And then the second part would just be the same. So this weight in kilogram divided by height. And by doing this way, our data set would have recorded height in meters rather than height in centimeters, which was before. So actually, this is one way on which mutate function can be useful on how to play along with with the variables. Try to change, try to create, a new variable, maybe try to change the variable. But then again, we should always remember in everything that we are doing, we need to assign the output to something. That's very important. We did it last time. If you remember correctly, look at this at the environment around here. In every step, we created a new subset because we don't want to, to manipulate our raw data, but we can just create other subset of this raw data. So just in case, if it happens that there are some bugs in our code, we can just retrace our steps from the beginning to where, something happened, which leads to an error. Okay. So do you have any questions on what I've just explained? So here we can just assign it to anything. So we end at HIV data. Set the code, to call this set 5. Maybe this HIV data. Set the code, can call that. Okay, so if I run both of these, I can see that we have subset of the output that we had. So the number of the subsets here are increasing, but this is very important because we are sure we can always retrace our steps. And if something happened along the line, we can just retrace to the very specific line that caused that bug. So do you have any questions on that before we try to look at other functions of Mutate, how we can use Mutate?
Yeah, thank you, Ludovic. I was thinking,
Yep.
I'll just post a short code that we can use to actually classify the BMI.
Okay.
Yeah, then we'll just discuss it shortly, but you can just continue in the meantime.
Okay. So as Duncan was said, we can also use Mutate to create like classifications of or create maybe subgroups in our data set. So for instance, okay, so maybe it should wait for the code. Okay, so so let's see. Let's look in our data set. For instance, okay, so for instance, we can look at the BMI itself. So for instance, in the BMI itself, the BMI is usually classified into, okay, so we have obese, then, so less than 18.5, is it 18.5 or 18 point? Okay, so you correct me, 18.5 to 24.9. Okay, so, and then we have 25 to 29.9, and then we set on the back. So this we call them obese. These are overweight. These are normal weight.
I've posted it in the chat, Ludovic. We can use inside the mutate function. There's we can also use another function which is called case when. So this one actually enables us to classify when BMI is less than 18.5, we can say that's underweight. When it's above 18.5 but below 25, we can say that's normal weight. When it's greater or equal to 25 but less than 30, we can call that overweight, and anything above greater or equal to 30, we can say that that person is obese.
Okay, so
yeah.
So as Duncan was saying, we can also use the mutate function alongside, the mutate verb alongside these two functions, the case when, as well as the other function called the if else. So the first one is, this one is more, I think it's more useful because you can use it in multiple ways. This one is usually useful if you want to create maybe a Boolean variable that may be the one that has true and false, 1 and 0, something like that. So for instance, in the example that he was sharing with us, okay, so if you wanted to further reclassify the BMI that we had, right here, classification, BMI. So we can write something like this. So, okay. Okay, so we need to take this data because this is the one that created the BMI and put it here. Okay, so we can take the HIV data row subset 6, which is the subset that contained the variable called BMI. We didn't take any of the previous one because we don't have a variable BMI in this one. So we can start by this variable HIV data underscore row subset 6, and then we can use the mutate verb. And then in the mutate verb, okay, here it won't be BMI category, be BMI, the name of our variable, and then BMI equals to case when. So whenever we find BMI is less than 18.5, we have this tilde sign. Everything that is less than 18.5 will be underweight. Everything that is greater than 18.5 and is less than 25, it will be a normal weight. Anything that is greater or equal than 25, but is less than 30, it will be overweight. And anything that is greater or equal than 30 will be obese. So if we run this, our BMI, okay, so maybe to appreciate what's going to happen, we can just run this first and then call HIV subset 6. Let's see what we see. Okay, so if you run, we look at this. What we have here is the BMI. We have the variable BMI with numbers. So we have 20.6, 27, 36, 42, etc. So if we run this, let's see what we'll get. So this will be subset 7. So if we run this, this be subset 6. What we're supposed to do is okay. Okay, so let's look at the BMI and see what has happened. So the numbers are no longer there. So what has happened is from this code, we have used mutate verb to reclassify the numbers into these 4 categories. So the numbers are no longer there. And what we have now is normal weight, overweight, obese, etc. Based on on the findings, if the BMI that was here was either less than 18.5, was either between 18.5 and 25, or maybe 25 and 30, or maybe more than 30. So apart from creating other columns, we can also continue to manipulate those columns, trying to get what we want. So for instance, say, we may say maybe we were only interested with those with, okay, so maybe we can do the same for age. So maybe we can just copy this code, put there, call this subset 8. Okay, let's leave it as it is. So we can say mutate age and case when, so you can say case when age. So we can say maybe age, when age is, so we can say, maybe create here. So we can say maybe any age less than 18, and then we'll say 18 to 50 to less than 50, and then we'll say anything from 50 and above. So say we take this first. So anything less than age. So when age is less than 18, we call this maybe children. And then when age is from 18, and here when age is less than 50, we'll call them maybe adults. And then the last one, when age is more than 50 years, more equal than 50 years, we'll call them maybe elderly. So if we run this, we call subset 8. What we are supposed to see, we'll see the reclassification of age column based on these 3 categories. So let's see if that's what we see. Okay, so if we come down here, we can see in the column age, what we have now is adults, children, elders. So if here the age was between 18 and 50, they'll be reclassified as adults. If here the age is less than 18, they'll be reclassified as children. Now, the importance of why we need to create these subsets is because maybe after a while, you may be interested with the original data and you want to manipulate that to create maybe new columns or new manipulation. As you can see here, we no longer have the numbers that we wanted. So we cannot maybe calculate the mean age. You cannot know the median age. And then we'll have to retrace our steps back maybe to the original data. So the original data had everything. So if you have it and we have not changed anything in it, you can always go back and reuse it if need arises on the later stages of your analysis. So this is another way on which we can use the mutate function. But we can also use it to create the, with the if else, with the if else, can use it with the if else function to create variable. So we can create a variable which is true and false. So how can we do this? We can say, for instance, we'll take the age. Okay, so maybe don't need the whole code, maybe we can just
Ludovic.
yes.
So there's a question from Vivi.
Okay.
Asking how you create those subset data subsets.
Okay.
And maybe you can explain why it's important.
Okay. Okay. So we create the subset by using this the assignment sign. So you can write here. We use the assignment sign. This thing. So we use this thing, the assignment sign, the arrow pointing to your left side. So we use this to create the subset. So for instance here, actually the code that gives us the output that we want is this. So we take the dataset HAV underscore row underscore subset 6, we pipe it into the mutate verb, and then we created this category to have the categories that we are interested with in this BMI variable. And then by doing this, we have the output that we want, but we want to assign this to a certain bucket or to a certain place so that whenever we want this data set, or maybe we want a data set with these variables, or with a variable that has been manipulated into our needs based on underweight, normal weight, overweight, and obese, we can always recall it. So how we do that? We use this assignment sign. So you write this code, and then to assign it, you just you just say that everything, all of this will be assigned this sign to this name. So this name, HIV data underscore row underscore subset, will produce the same output as when I try to highlight this and run that line. This is very important because, as you can see, I was just explaining it a little bit earlier. So, okay, you can see, for instance, if you look here, when you look at the age variable, you can see we have numbers. So we have 24, 83, etc. So from these numbers, because this is numeric variable, we can always do some manipulation, like we can calculate the mean, we can calculate the median, we can calculate maybe interquartile range and all those stuffs. But when we came and manipulate our age variable and create these categories, and we have this, let me run this, and then we can have, okay, so, okay, so that was for obesity. Okay, I'm supposed to run this, and then run it separately. Okay, so here we can calculate all the numeric, summaries that we're interested with, mode, mean, median, interquartile range, etc. But here, how can we know the average age or maybe the median age of the participants in this data set? Because what we have here, we are just told that this number of participants, these participants were either adults or maybe children or maybe elders, those three categories. So here we won't have those numeric summaries that you might be interested with. So you might need this, for instance, if you need to visualize based on these categories, whether they are adults, children, or elders. But sometimes, apart from that story that you're going to tell us using that visualized version of these variables in this categorized way, you may also be interested to tell us what's the mean, what's the median, etc. So if you have lost this data set and you have not saved it, by the time that you need to explain that using the median, the mode, and etc., that data won't be there. So that's why it's advised in every step you need to assign the new data set, and everything will always be at the environment. And you can always come back and say, okay, fine, I'm interested with original data. Did it have maybe, okay, the age was in numeric form, or maybe what else did you change? We change, okay. Okay, and then when you look at subset 8, the age now is not in numeric form. Now this looks like characters, this is a category. So that's why it's important to do all this assignment. And we just do the assignment by just adding this thing, the assignment sign. So just adding the assignment operator, you can assign all this code to that. Okay. Okay, Vivi, was that clear? Okay, so thank you. Okay, so another way we can use the infers function, and this we normally use if you want to create a variable that has only 2 entries. Maybe you want to reclassify age into children and adults, or maybe children and everyone else who is not a children. So we can say age rather than writing the case when. Here we write infers, and then we'll say age less than 18 age is less than 18 years is children. And then, okay, so let's try this. If it will work. So let's try this if it will work, and then we'll see. Yes, I think I've missed something here. So we can always, okay, so every time when you write a code and then maybe there's a bug and you don't know what went wrong, you can always So with R, there are a lot of functions that can help you with the helper functions, how you can see if the code is right or wrong. For instance, here we're interested with the infers function. We can just write a question mark before infer and run this. And then if you look around here, you'll see some explanations. They will be at let me see what okay, so they'll be here around the help. So here you have a help like a help function, a help tutorial that tells you about how to use the if else function. So the user, you say if else, you write the condition, which is this condition, and then true, if false, everything else. So, and then down here, we always have an example, okay, of how we can use it.
Yeah, I think in line 242, there's after
yeah,
there's that tilde. I think it's supposed to be a comma. You see, after 18, there's that wavy.
Okay.
Yeah.
This way.
Yeah.
Okay, so okay.
Maybe try it now. The comma.
Unless it's something because of the subsets. Let me say. Okay, so maybe let's use the row that was it. We call this 9. Nope.
Okay. Maybe after children, after the comma after children, we can say adults as a string, so that it actually means
two options, right?
Yeah. So that it means if it's less than 18, it's children. Otherwise, if it's false, then it's adults. Yeah, let's try that now.
Think that work?
Yes, that has worked.
Yeah. So okay, so if that can come intuitively to you, that's fine. But you can always come to this help function, and then you can look at how that specific function can be worked on. So thank you, Duncan, for troubleshooting that. And I think we can always come to here and then, so for instance, this if else x, this is a condition. I know you want that. Okay, so it's just exactly like this. So what Duncan was saying, you can see, you can just get out of here. So here they use the data set called stars, they mutate, and then in category, they want if else, if height is less than 100, just like this, it will be short. Otherwise, it will be tall. So you can always come to the help function, and then maybe you can type here whatever you want to check how to use the infers function. And if you look careful in the examples, you'll always find a code that can help you on how to debug whatever is not working to you. But in this instance, we didn't need that because actually we are blessed to have an expert around. So from here, what will happen? We can call this here and try to look. So what happened is the age, variable has been reclassified into only two categories. So now we'll only have the adults and the children, and we won't have anything else. So we only have adults and the children. So this summarizes the many ways on which you can use the mutate function. So as we can see, we can create a new variable with the mutate verb, mutate verb, not function. We can also change the content of the variable. For instance, if you want to change the variable from 18 meters to 18 centimeters, and then we can always use the case when function alongside the mutate to try to be a little bit free on what we want to do with these variables. So if you want to create subcategories in our data, we want to create maybe certain names that we think they are relevant to whatever we are doing in these subcategories. And then we can also use the infos function if you want to create the Boolean variable. That is only 2 entries, maybe yes or no, children or adults, 0, 1, etc. Okay, so is there anything, any questions, or you can add if there are any inputs, Duncan?
No, no inputs for me. That is well covered. Thank you.
Thank you. So maybe to summarize, can look at this. So here, this highlights the key differences between the case when and infos functions. So we use the infos function usually when we try to create a binary condition, true or false, yes or no, adults or children, such kind of a variable. But we use case when we have multiple conditions and we want to be a little bit flexible. So here we can just write the way we did, like we created different categories of BMI from underweight to normal weight, overweight to obese, which may be, helpful when we want to do we are continuing with our data management. So after that, we'll have a brief a look at the summary and group by. Okay, so sometimes, most of the times, whenever we have this kind of different types of variables, we might be interested to get the high-level picture of what they entail. So things like, what's the mean among these observations? What's the median? Is this mean the same maybe for a female when compared to the males? And when we want to do to view those kinds of summary statistics, we usually come and rely on summary and group by verbs in our dplyr package. So maybe we can go ahead and try to see how we can use. So for instance, if you want to say maybe, let's look at our original data. So maybe if you want to say what's the mean age, or maybe what's the median age from all these observations that we had. So by using summarize, we can just go ahead and say maybe HIV data row, which was the original data set, and say maybe you want to create mean age of the whole data set, which will be equal to mean of age, so from this line, okay, or maybe you can code, age, age. Okay. So maybe we can start with this and then I'll go ahead. So from here, we want to summarize what's the mean age of the participants in this data set. So the mean age. So we'll come here and say, summarize. We want the mean age. So we can just write this intuitively, maybe the mean age, or maybe anything, maybe MN age. And then if we run that, okay, meaningful. If we run that, we'll get the mean age was around 42.204, all that. So we wrote this second part, the na.rim, to remove all entries that were not there. So the NAs. So these lines, this line removes Means the n is valid. And we'll see that whenever we use the operations that we want to calculate, maybe the mean, the median, the mode, we always write this so that it may not affect the way the R is trying to calculate the mean or the mode or the median, whatever. So we'll always use this at the end of the line, but this is the line that will give us the mean value of whatever that we want. So this is an example on how we can calculate the mean, but that's not the end of it. What we want is to be able to try to use that alongside the group by, because most of the time you'll find that you're interested with knowing maybe the mean age around, the mean age among women and the mean age among men, female, and try to compare those groups or something like that. So we can say, okay, so maybe here we can, so let's say maybe group by what? We can group by gender, and then we use the code above, maybe calculate the mean. The mean age, here's the mean age, okay, so what we get here, okay, remember our gender, because we used the original, data set, our gender was by then coded as 1 and 2, which is not right. Maybe you can do that into, okay, so we can say maybe we can and say gender goes to and then maybe goes to gender, goes to person, gender equals 1, for the tilde.
Yeah, for the tilde, it's off.
Okay, so this female, and then gender equals 2, we may call this male. And all of this okay, so what we've done, we took the HIV data set, which we had originally, and then the gender variable was originally coded as numeric, which is not okay. We're supposed to be a factor because it was called numeric because it had 1 and 2, but that was wrong because these are just category male and female. So we changed it into as factor. And then in this line 271, we introduced the case when, which we've just learned. So case when gender equals to 1, it's supposed to be female. And then when gender equals to 2, it's supposed to be male. And then after that, we said group by gender. So we want everything that will come after this to be grouped by gender. And then we want the summary of mean age by these two genders. And then what we get out of here was, for female, the mean age was 42.3. And for male, the mean age was 42.1. So it was around that. And you'll find that this will always be very useful whenever we're working with data. So as you can see, we've been building up into very small steps, but as we go along, you can see, okay, this is just a normal code, and then this is something that we've covered. But when we put them together, they're so intimidating, but they're just tiny bits of small codes just added on top of the other. Okay, so is there anything that you can add on that, Duncan, before I go ahead?
No. Nothing so far. It's good.
So, so, mhm. So maybe sometimes you may want to, okay, so this was for maybe one summary statistic, but you may be interested with getting many summary statistics at once. So let's see if we can do it. So that, and then we say median edge, equals to median, right, and two, and then maybe what else do you want? Maybe the quarter range, if you are, okay, equals to, you are, and two. So we can see, we can also have multiple summary statistics by just add them on top of the first layer that we had. So from this line, we could only have the mean edge, but here we have the mean edge, we have the median edge, we have the interquartile range for the edge. So that's another way on which you can just continue to build up on different summary statistics that you may be interested with. Okay, so we can, so maybe we can come to this question. It says, question 5, use group by and summarize to obtain the mean weight in kilogram by occupation in the HIV data frame. Name the average weight column as weight mean. So they want us to group by by occupation. And then they want us to calculate the mean weight. So from this, we're supposed to get, I mean, which occupation is maybe they are the heaviest or maybe they are the lightest. So we take the original data and then, why do we need mutate here? Because I think we can just skip this. We'll see if we need it in the output. And then we can say group by occupation. And then summarize what you're supposed to summarize, the mean weight. So mean weight equals to mean and then weight in kilogram and .rm removes all the NAs and let's see. So this is what we have. So from here you can see that the mean weight was around 73. So the businessmen and businesswomen had the mean weight of 74, the doctors had 73, the drivers had 75, etc. So here we've just grouped by their occupations, and then after that we've summarized by to get their mean weight. We can just do that for maybe, let's say, okay, maybe by HIV. Let's copy this and say, let's group this by HIV status. Those yes.
Just out of curiosity, is it also possible to actually group by occupation and HIV in one line?
Yes, you can do that, and that's called nested grouping. So you can also group by multiple groups, right? So we can say group by HIV and then group by occupation. Okay, so if we do this, what we'll see, the number of rows will increase, and the reason why they'll increase is because what R will do, so we can see we have 22 rows. So we have HIV first, and then we have the occupations, and then here we have We still have HIV from. So what we see here, we started with HIV, which are grouped as 0. So it will have all occupation for those who are HIV, let's say negative, who are 0. So you'll have all occupation for those who are HIV negative, and then it will have all occupation for those who are HIV positive. So the number will increase from the original 11 for all the 11 occupation to 22, because the data set will be first grouped by HIV into the two groups, two HIV categories. And then within those two HIV categories, it will further be grouped by occupation. So we have two HIV categories, and then we have 11 occupations. So there will be 22 rows. So you can do that. And this is called nested grouping.
Okay, great. And maybe just to say that this may also be similar to what we do in Excel, that is the pivot tables.
Yeah, okay.
It's close to that. Yeah, thank you.
Okay. So this is another useful, another practical use of how to use the dplyr verbs. So we can always, jump around between them, select, then you filter, you mutate, and then after that you can group by this, and then after that you can summarize. Okay, so before we go ahead, so maybe we can come to this. So usually after completing your grouping and maybe get the summary statistics and everything, we are usually advised to ungroup everything before we go on with other manipulations. So for instance here, we have said we have created HIV data underscore row, and then we group by HIV and occupation, and then we've summarized our data. Let's say we have assigned this to a data set called maybe HIV groups, nested grouping, nested underscore grouping. Okay. Okay. So HIV. Okay. So suppose I'd like to ask a question. So if in the future I'll be interested with using this data set called HIV nested underscore nested underscore grouping, and then say maybe I want to use this for maybe modeling, or maybe I want to use this for maybe trying to understand, trying to find maybe what's the mean, what's the mode, what's the median. What challenges could have come from this? There are no wrong answers, and I think you can say anything, whatever that comes into your mind. So if I want to use, for instance, this data set that we've just created here, and I want to use this maybe for later on to create models, or maybe to create visualization, what challenges may arise from using this data set, which has grouped summaries, maybe by HIV occupation, or maybe as any other grouping summaries? Can we have any challenges in our end product, or maybe in our visualizations, or maybe in our models? Anything? You can even post anything on the chat. What do you think could have been a problem? What could have been a problem, and why? And which could explain why we need to have another dplyr function called ungroup. So we are trying to build the case on why we need ungroup. So we've just summarized, we've just grouped by, and then summarize our data set, and then after everything, we have to ungroup. Why do we need to take all that trouble? Is there anything that comes into your mind?
I think the data is already deformed, so
Yeah. Okay, so that's one.
yeah.
So the facilitator helped us. That's one thing. The data may be deformed. So which means that your models won't be accurate. Your visualization may be missing. Okay, it may be easier to misinterpret what you are seeing because they don't capture the reality. And then, for instance, if you are to calculate the mean out of this, it won't calculate the mean for all ages in this data set. It will calculate the mean out of these groupings here. So it will take the mean out of these, maybe these 11 categories, or maybe these 22 categories, which may not be representative of the mean of age among all the observations from here to here. So there are always dangers of using grouping data just after their usefulness is no longer important to you. So normally, after doing everything, at the end of everything, we usually encourage to, so after finishing with the manipulation and everything, you can always ungroup your data. And that's especially if you want to use this thing for your further manipulations, modeling, or maybe if you want to do some visualization. And that's because you don't want to encourage calculations and say maybe the mean age was this based on your data, but then what you are seeing is they're just errors because you use group data in a place where you need, single observations to create maybe the mean or the median or the mode. So that's why we always encourage to ungroup our data just after finishing with everything that we're interested. So we've just summarized and everything, and then after that, we just encourage to ungroup your data. So I'll just test this. Okay, so do everything, and then after that, you have to. After that, you just ungroup your data, and then you can continue with everything. And then the other function that will be the last one is the count function, which you can use to just count the number of maybe the observation that we are seeing in our data set. Okay, so let's say, for instance, okay, so if we get the concept of why we need to ungroup our data first before we finish with the count, or maybe there are questions around that. Do we have questions? Okay. Or maybe let's say, okay, so maybe we can finish with this. So maybe group by. So we can use the two categories that we are familiar with, group by age, or maybe group by gender. And then take this into the count function. So we can use the count function within the summarize. We can use it within here, or we can use it by itself. So here we can just say maybe summarize, and then we can say count equals to n, maybe this. So this is going to be to give us. So this, what we'll do, it will tell us we have grouped this by two groups, HIV and gender, and then we have summarized to request for the count in each of these of the categories of gender. So in HIV, we have two categories, 0 and 1. This, as we said, is nested grouping. So it will first group by HIV, and then within HIV, it will subgroup it by gender. So we have HIV, we have two categories, 0 and 1. So the two, and then we have two genders. So we have 0 with females and 0 with males, and then we have 1s with females and 1s with males. And then it will give us count in each of them. So as we said, maybe if 0 is HIV negative, there are 699, if this is females who are HIV negative. And then there are maybe 68, 66 females who were HIV positive. And then likewise, there are 658 males who were HIV negative, and 77 males who were HIV negative. So that's one way on how we can use count. The other way is what we had read last week, I think somewhere around, okay, somewhere which, and I expected that you'd have asked me because we use it around here. So we said we use the original data set and then we filter based on a certain condition. And then we wanted to know the count in that condition. So how many people had that condition? Okay. So for instance, here, we could have said HIV data row, and then maybe filter, and then the condition was maybe HIV status, code, okay, so 2, 0, 1, equals 1. And then out of this, we want to know how many people fulfill that condition, regardless they are female or male. So if we run that, we know that 143 people were HIV positive. And how we can verify that by using this code above here and take 66 plus 77, which also give us 143. So we can use count within the summarize, we can use count on its own. Okay. Okay. And then, okay, I think this is the last one. So by default, the arrange function will always be in ascending order, starting from the smallest number to the largest number. But we can always change to make it start from the largest number to the smallest number. Okay, so for instance, here we can say maybe arrange. Okay, so let's see. Maybe say arrange gender. Okay, so maybe we can say age. So here we say arrange age, and then everything has been arranged from 0. And then we'll find that at the 100 observations, you'll start to see the age is increasing. But what if you wanted it to start from, the largest number, we can just add descent. And if we run that, it will start from the largest number to the smallest number. So this wrap up several dplyr packages that may be useful. And when you look at them one by one, the codes are just simple. It's just that when you try to mix and try to use them together, you start to see the code is confusing, but it's not really that much confusing. I think you can just go ahead and try to understand it if you take some time. So for instance, if you look at this, we can see that saying HIV 0 and HIV 1 doesn't even make any sense. So if that's the case, it means maybe somewhere here we're supposed to mutate and change these things. So change 0 to positive or 1 to negative. And then we're supposed to do the same for gender. And then after that, we can group by gender and HIV, and then we still get the same thing. So as you can see, we can just use the mutate function and the case when, which had previously, we just mutate these things and they'll still make all sense. Okay, so I think that will be over for today. We still have 10 minutes. Do you have any questions before we jump to multiple choice questions? We still have 9 minutes.
Yeah, Ludwig, I think there was a question Frank asked. Now,
Okay.
since you're at the end, how does he that PDF?
Okay.
Yeah.
So this document that we use is called RMD file. So you can get it by start here. So if you go to the file and then you create a new file, you can see here you have R Markdown. Okay, they also have Quarto. I'm not, I don't know much of this, but you can always use the R Markdown to write your course like this, and maybe at the end of the day, create reports. So these reports, the outputs can be in different forms. It can be in HTML document like this. It may be in PDF. It may be in maybe PowerPoint presentation. And then when you finish coding, like how we've done here, you can always come and click this thing here, like it's written neat, so you can come and click the neat button, and if we click it, oh, okay, so I still think, okay, so if you have click it and then this program neater is run, and you'll always see some, okay, so saying no file directory. But actually it was supposed to run, and then the output will be like this. I don't know why it's not running now, but the output will be something like this. Okay, you may try. Can you try to click this and see if you get an output? So you'll see numbers start running around here until 100, and then another document will pop out, which will be the HTML file which you've created, whether it's HTML file or maybe PDF file, etc.
And maybe
yeah.
if we click that drop down on the neat, we see the options which are there.
Yeah. So you can also see the options here. So yeah,
Maybe
HTML
we
file,
try the first one, you see?
yeah, so you can just click this, and then the output has changed. You can see here the output now is all default, and HTML default. You can just come again, maybe say PDF. So to change again. Yeah. So that's how we get that document. Omari said, can you share all the course resources presentation after the training? I believe they've been shared in the platform, right?
Yes, Dr. Omar, what we actually do, we normally share after every session. So after every session, you can go to the platform and check it there. We always try to make sure that, yeah, you can open the e-learning. Yes.
So you can come. Maybe we can post.
Yeah. The link, yeah. Everything is actually there. So you can, if you have time, and Dr. Ludovic will also share the exercises which are there, and you can see.
Actually, they're actually there. So we have quizzes.
Yes, they're actually there. So you can go there after you've read, you can just try yourself the quiz. And in case you have any question, please feel free to reach out to us. You can write to us via the platform R for Fun Club. You can post your questions there, and all of us will try to answer any issues that you actually raise.
Yeah, and I think maybe to add on what Frank had asked earlier. So Frank, this file, which has everything that you're interested with, all these things and all this line and how the lines will appear after you've run them, is what you are going to see when you click into this module 2. So if you open into module 2, you'll find this document. You'll also find the quiz. Actually, so the quiz is just there. So you can just go there, and after reading this thing and try to follow it in your with your laptop, with your RR Studio, you can always go to the quiz and see what you see. So if it happens that maybe you have bugs, certain codes are not running, you can always say what is not working and maybe share the code that's not running. Then you can try to troubleshoot from there. Okay. Otherwise, thank you so much for being attentive and taking your time to be with us today. We really appreciate. And actually, okay, I think I should share one thing. Okay. So actually, this is the just a take-home message. So we should always have patience, especially with code. Everything seems so difficult at the beginning, but as you go along and try to look at them, you start to see some patterns. Okay. For instance, me, I'm not an expert in these things. I just have interest in them, so I keep trying to learn whatever I see, try to understand them, try to ask them from Ashna and Duncan, and they're very helpful. So along the way, I feel that even though I'm not an expert, I can start to see some patterns. So I know if you have this, something else should come around here. I know where to go if the code is not working and things like that. So we should have patience, take your time, and then these things that looks difficult now will be easier as time goes along. Thank you so much.
Thank you so much, Ludovic, for the encouragement. And Dr. Omar, yes, everything will be shared on the platform. The presentations, the R Markdown files, everything will be shared. Plus the quizzes, you can always try them, and the course, everything will be there. So I take this opportunity to thank you so much, Ludovic, for those two sessions that you've had last week and this week's. So I really want to encourage you that next, let me share my screen. I want to encourage you that next week we will be having the training of tidy data and data wrangling with Tidyr, which will be covered by Ashna. It's also a very interesting, it will be a very interesting session as well. Same as Ludovic's, how you actually, and you see, as Ludovic mentioned earlier, is that data cleaning actually takes almost 70 to 80% of data management. So it's very important that we actually get to know our way around that data. And thanks so much, Ludovic. It has been a very, very interesting session that you have taken us through, both at the session and the Alpha Fan Club session. So next week, please don't miss the session with Ashna, who will also take you through Alpha Fan Club in the other week. Okay, so let's keep coding, and in case you have any issue, please post it on the Alpha Fan Club page, and all of us will be there to assist you in case there's anything. Otherwise, I wish you a good evening, a good day, and a good night. We meet next week for session 3, Tidy Data and Data Wrangling with Tidyr by Ashna. Thank you so much, Ludovic, for your session.
Thank you so much.
And we meet you all next week. Thank you and have a good evening.